Education is what's important. Training, preparation for the expected. Education, preparation for the unexpected.
All right, good afternoon, Team Krulak community. My name is Major Ian Brown. I'm the Operations Officer at the Brute Krulak Center for Innovation and Creativity. And on behalf of Marine Corps University, the Marine Corps University Foundation, and the Krulak Center, welcome back to the Brutecast, our series designed to connect the worlds of the warfighter and PME with the best in innovative and creative thought. Before we begin, please remember that all opinions expressed here are those of the individual and do not necessarily reflect the views of the Krulak Center, Marine Corps University, the United States Marine Corps, or any other agency of the U.S. government. We'll also be recording this webcast for the benefit of those in our community of interest who can't join us today. So we ask that you be mindful of keeping your microphones muted to avoid disrupting the presentations, as well as keeping your webcams off to help stream smoothly during the presentations. At the conclusion and following some discussion among the panelists led by Dr. Wilhelm, we will have a question and answer session. So as the presentations are going, if you come up with a question, go ahead and enter it into the chat and let us know that you'd like to ask. And as long as your device and connection supports it, I'll ask on you to ask your question directly to the panelists. If you're not able to do that for some reason, just indicate it in the chat and I'll ask your question for you. With that, I'm pleased to turn things over to our panel moderator, Dr. Leslie Wilhelm, from the Office of the Deputy Assistant Secretary of the Navy for Research, Development, Test, and Evaluation. Dr. Wilhelm, over to you.
Thanks so much, Ian. Greatly appreciate it. Thank you all for joining us on this next installment of our series on regaining the strategic initiative in the South China Sea. This series is about framing the problem differently so as to pose better solutions. In that vein, I am so excited to welcome Mr. James Kaley, Director of the Operational Energy of the Deputy Assistant Secretary of the Navy for Research, Development, Test, and Engineering, Dr. Ben Richardson, Portfolio Director of the Advanced Energy and Materials at the Defense Innovation Unit, and Mr. Erik Limpaecher of the Massachusetts Institute of Technology Lincoln Laboratories to speak to you this afternoon. Their insights into fuel and energy as it affects our ability to operate in all theaters, but in this case, in the case of this discussion on the South China Sea, are profound. It is an excellent follow-on to our previous panel discussions in this series as it further hones in our discussion and the actionable paths to affecting our ultimate strategic goal of deterrence. Subsequent to an excellent briefing by each of our panelists, there will be a brief discussion between them on questions relevant to how their areas of expertise support deterrence and assurance of allies and partners. Jim Kaley was appointed as the Director for Operational Energy in September of 2016. He serves as the Secretary of the Navy's focal point on all matters pertaining to operational energy. Jim came from the United States Marine Corps, where he served in the transportation, logistics, and communication fields since 1989, rising to the rank of colonel. He's an experienced operational and strategic planner on issues relating to the Asia-Pacific, South Asia, and Middle East. He is commanded at the battalion and regimental levels. His final post was as Director to the Marine Corps Expeditionary Energy Office, where he was tasked with coordinating innovative energy technology and policy development for the Marines. During his time as director, Jim refocused the Marine Corps' Expeditionary Energy Concepts Initiative to focus on developing infantry-related technology in concert with private industry. His current focus is on fuel distribution in contested environments, power and energy for directed energy weapon systems, advanced batteries, advanced propulsion, persistent intelligence surveillance, and reconnaissance. Ben Richardson is the Director of the Advanced Energy and Materials Portfolio at the Defense Innovation Unit. Ben and his team are responsible for delivering strategic energy and materials capabilities to the military by accelerating the adoption of commercial technology and strengthening the national security innovation base. The AE&M portfolio is focused on three primary lines of effort: advanced energy and storage, alternative storage and mobility, and materials and sustainment. Mr. Erik Limpaecher leads the Energy Systems Group at MIT Lincoln Laboratory, a Department of Defense federally funded R&D center. His team focuses on contested fuel logistics solutions and the energy resilience of DoD installations. Erik's team has engineered advanced fuels for ground and undersea platforms, hybrid power systems for remote bases, and performs power outage exercises of large defense installations. His teams have won 3 R&D 100 awards for transitioning technology to industry. So as you can see, we have a very esteemed group of panelists. And with that, I will turn it over to Mr. Kaley to start us off. Thanks, Jim.
Awesome. Thank you, Dr. Wilhelm. So as I begin the discussion today, I'd like to put the caveat out there that, I'm certainly no expert on deterrence, and in the field of energy, there is an awful lot of, scientific expertise backing me up in what I do to support the Navy and the Marine Corps on a daily basis. I will tell you that I've read a little bit on this thing, and I do this a lot of times when I, talk to folks that are interested in this field. Like, my recommendation is there are a lot of different books and articles for you to read. And if you want to know the basis of the slant in my view, it's kind of based on the books that I'm putting up, or that I put up there in front of you, and things that I focus on. So, the Navy and the Marine Corps is a great team, and they're full of smart people, and they can do this, right? So I would tell you that all of those systems that you see on the left are examples of systems where the Marine Corps is succeeding and failing at the same time. When I say and failing, we're not very good at pointing out our flaws. When we go, we want to show our successes and write successes into awards and things like that, but we're not good at talking about our failures in those spaces. Every single one of those systems up there that you see on the left represents some kind of power and energy failure or problem that we have to deal with. So if you look at them, the problems that they provide are things like an increased logistics tail. That ship down in the bottom has to be refueled every 2 days if it's running at full speed. That's ridiculous for naval capability and combat environment, right? Then you have unnecessary readiness costs. We overrun our trucks like the MTVR and Humvees because we have to charge batteries that are put on the Trip 7 howitzer and on the capability that's put on top of the NOTAM, and we literally overrun the life cycle of our assets. This doesn't even include what we do to airframes, right? So we use systems ahead of the life cycle. Then we attempt to put capabilities on ships. And in the case of the tow missile system that you see above there, we spent years not being able to get the batteries for the thermal optics on board ships because they weren't safe enough to get on board platforms. Then you look at the Harris radio there, and you look at the generator down below. The Harris radio is 40% overpowered compared to what we need. And that generator down below, we waste about 65% of the fuel going into it. If we're going to fight in an anti-access, area denial environment, we need to provide a credible force, a force that doesn't have a UAV that stays up in the air for between, an hour and a half and 4 hours, but a UAV that stays in the air for 4 days. A generator that produces power on demand and that we don't waste 65% of it going forward. Why do we need this? Because we need to provide credible force forward that doesn't have to be resupplied, that we can't kill through its resupplied lines on an extremely regular basis. I talked previously about how the Marine Corps and the Navy are struggling in this space, but the question here is, how do energy technologies help in deterrence? Well, the first thing is that what I wanted to do was go over some of the basics of how I think about deterrence. And you can see that I credit Adam Lothar and Michael Codner down there with giving me this framework. The point that I would make is that deterrence is all posture and action short of full-scale combat. It doesn't include dissuasion, which is usually, considered part of diplomacy, right? And then on the physical side of the house, deterrence is about the ability to provide what is viewed as overwhelming force, credible violence, or evidence of dominant capability, right? So the enemy looks at our capability and assumes that we can outgun them or something to that nature. On the cognitive side of the house, deterrence includes symbolic actions, limited use of violence, and things that alter perceptions. And the point that I would make here is that, in the Navy, we're actually really quite good at these things, and doing things like refueling at sea right in front of the Chinese Navy is one of those things that demonstrates to the Chinese that we have credible capability that we can push forward. and that we can maintain that capability. And you say, well, why is refueling, part of that altering their perception? Because the Chinese have their own carriers, and so they understand how long a carrier can stay on station without being refueled, and they understand the limitations of that capability. And the truth here is that the Navy in the Pacific without refueling capability turns into a 7 to 14 day salient, just like that. And so things like demonstrating the ability to resupply our force under threat and in combat situations in contested environments is critical to making sure that we can convince peer competitors and near competitors that we're capable. So what matters? Well, perception of legality, morality, and entitlement, those things matter. And you can tell that, the Chinese also agree because they continue to contest legality issues inside the first island chain, how large Chinese territory is, the contested atolls, contested islands, contested fuel platforms, fishing waters, etc. Then there's the perception of capability to deliver that violence, as in, do the Chinese or another near peer competitor think that we're capable of doing that? Do we have the will to do that? And that obviously is a political and national will question. And then do we have the reputation that we can implement these intentions credibly and effectively? And so in the world of being able to deliver violence forward, the question is, can we do it credibly? And as you saw on the previous slide, we can do it, but it comes with an incredible logistics tail that is super easy to target in an A2AD environment. So how do the Chinese think about energy? So I would tell you that kind of, from two perspectives, one, the less contesting perspective is that the Chinese feel like, they have these initiatives so that they can expand trade and that they can expand opportunities to be able to have access to energy, critical minerals, and frankly, factors for manufacturing, because obviously China has a super great manufacturing capability, but all the factors come in from other places like, Southeast Asia, Africa, and places like that. China recognizes that it needs its energy to be successful. And so it's very focused on energy infrastructure and frankly, naval bases and naval capability to secure sea lines of communication. And if you were paying attention to The Economist and other credible publications, when the COVID stuff went down and fuel prices plummeted, you'll notice that the Chinese bought up a significant amount of the glut in both global oil and global fuel that was sitting on the ocean. And so they used that opportunity to expand their national reserve significantly. So that's the first perspective that we think about it. And then the second perspective that we think in is competition and expanding towards conflict. And, the bottom line here is that China makes doesn't hide the fact at all that they claim a lot of offshore infrastructure. They claim a lot of offshore territory, and a lot of those things are tied to, Sunoco and links to oil production and things like that, whether it's happening in what we think are Vietnamese waters or whether it's happening in Chinese waters. It's a matter of perception in this particular case. The other point that I would lay out here is that, while we in the Department of Navy have focused really hard on producing, sharp, pointy, excellent sticks to go and kill people and break things. The truth here is that the Chinese have been telegraphing their strategy on how they deal with opponents since Sun Tzu, right? Attack alliances, then attack logistics. And if you look at unrestricted warfare, you will see that carries right into their doctrine on unrestricted warfare. And if you read the last couple of Chinese defense white papers, you will see the same thing. And so one of the things that we are trying to do in the energy field is account for this and be able to provide a more credible logistics capability in the fuel space to be able to support fleet operations and expeditionary advanced operations in the Pacific. So what's the threat? So the challenge in this particular space, particularly as it pertains to fuel, is that fuel can be targeted and is targeted in phase 0. It's targeted in phase 1. And if it's targeted in phase 1 successfully, we're already behind the power curve and cannot maintain the tempo that commanders want to maintain in combat. It constrains fleet operations, period. And the challenge in this particular space is that the Chinese have good military analysts. They understand and they know how it constrains fleet operations, how it constrains US military operations. They understand and have weapon systems that target our ability to refuel our fleet or target our ability to refuel aircraft. And a point that I would make here is that we're talking about a near peer competitor, but if you see those top 2 pictures that are on the right, those aren't even the results of near peer competitors interdicting our capability. That's anti-access area denial done by not near peer competitors, but supposedly, not very capable fighters from the third world, and yet they're capable of constraining our actions and interdicting our fleet. Now, the big challenge in this space is, previously when we've studied it, we focus all our war games on, hey, when we get to phase 3 and we want to bang our cars together and, kill things and break toys, we focus our war games on that. But on a strategic level, literally, it's the logistics that are going to win everything. And those assumptions have been going out in the last couple of years. And the Navy and the Marine Corps are now finally working together, and now with the Air Force, to kind of address the logistics requirements going into early phase operations so that we can understand the threat better and account for it better. Point I would make here, vulnerabilities increase as you get further away from CONUS, and lines of communications are not, they constrain us and they're easily identified. And you could say, well, ships can go anywhere on the ocean. But if you are familiar with maritime control systems, you understand that every commercial ship at sea today has got a signature, and I can tell you what's hauling it or what it's hauling. And that includes Navy oilers that are on this system. And I can tell you exactly where they are and how fast they're going. And so my point here is, our near peer competitors have a lot of information about us, and they're capable of attacking us in ways today, and do attack us in ways today that do not look like missiles flying at you, right? They can attack our fuel depots with cyber attacks, and they do attack our fuel depots with cyber attacks. They are capable of addressing our supplies in terms of getting after the ability to affect transportation to our depots and things like that. And so the challenge that we have in this particular space is bringing everybody along so that they can operate in an environment where logistics is not assured, it's not guaranteed, your fuel supply may not come, and you can still be effective and credible in delivering, rounds on target, or handling contested spaces in this environment. So what do we have to do? Frankly, change the rules. So how do we change the rules? I did put up on this slide a couple reasonable lessons from, the last couple of wars. And, all lessons from previous wars don't apply to the next war. Otherwise, the Maginot Line would have been successful, and we knew that that's a complete, utter failure. But my point here is these are some reasonable lines that we should get after. The first one is we're not very willing as a country to take casualties. The second thing is that in the last 2 wars, particularly, the Marine Corps and the other services, but very much the Marine Corps was very good at showing that you could use smaller forces and close the sensor shooter link to be able to aggregate greater fires on a target without using a large number of forces. So the talking point that I often use is that what used to be considered a regiment's battle space could be covered by a battalion. et cetera. And so you see things like that. The next piece here is lines of communications are super easy to target. You don't have to be a first world competitor to get after us with that. And then this is something that it's not my line, it's a line from one of the graybeards up at the Naval Academy. And he always says, you know, missiles beat hardening, missiles beat armor, period. So how do we change the rules and be more effective in that environment? Well, you know, these things make sense, right? Aggregate fires, not forces. Make isolated forces more persistent, overcome external lines of communication, complicate enemy targeting. Now you say, how can frankly, in this particular case, how can you complicate enemy targeting? Well, I got to tell you that one of the things that you do is provide more things for them to shoot at. One target, if you're a surface warfare officer, one target is a 3-missile problem. Shoot, shoot, look, shoot. 2 targets is a 6-missile problem. But once you get to 3 and more targets, the number of missiles required keeps going up higher and higher, and it gets to be almost vertical in the number of missiles required. And so shrinking down our logistics resupply and providing much more out there means that we complicate targeting for the opponent. Then the next thing that we go after is we provide weapon systems that operate longer, stay on station longer, and operate at reduced signatures. So that UAV that you see over on the right is an experimental UAV that we put together. We, the Navy and Marine Corps team, in conjunction with the Navy Research Lab, put together. I can keep it in the air for between 4 and 9 days. The best Marine Corps system today has a 4-hour time in the air, and it's being upgraded to have a 12-hour time in the air. Okay, we need to catch people up on what's going on and what the technology can do. We did it because we changed the way that we think about that UAV, not because we are brilliant, but because we took new power technology and managed that technology in a better way to give it longer range, a better time on station. Now it doesn't come, it's, you know, that power is not free, but this isn't a discussion on UAVs in specific. The next thing that we need to do is unmanned platforms. And then we need to use risk-worthy platforms, frankly, which means that using an oiler that has an awful lot of fuel, but the Navy has a very limited supply of them, is ridiculous when we could use a much smaller offshore support vessel that we could hide in plain sight because there are tens of thousands of them floating around the South China Sea, right? And, you know, we would be more effective in that particular environment. And then I think that we need to rethink pre-positioning. I'll get into that a little bit later when I get to the industry discussion. So the right question here is, how does energy help us in this particular space? Well, the truth here is that if I go away from fuel propulsion for vehicles and I go to hydrogen propulsion, for example, I can cut the heat signature in that vehicle significantly and the noise signature down to next to nothing. Right, that electric small boat that you see over on the pictures over there gives me the ability to have an engine that does not make a lot of noise. Now I have to redesign the hull to make the boat quieter, but my point here is that I'm getting rid of engine noise and things like that. The next, you know, big things about this though are directed energy weapon systems. Advanced lasers are the way of the future. And when I say directed energy, I know that the Marine Corps kind of leads the way in getting lasers fielded, and they're going to put a 10 kilowatt laser, you know, out in the field on the Mattis. And super impressed with the Marine Corps for leading the way in this space. And by 2028, we will be fielding 300 kilowatt weapons grade lasers, and we will need ways to get them on vehicles and get them deployed in support of Marines so that we can actually shoot down targets with significantly short laze times. The next thing that energy can give us is optical communications. Now, we all talk about communication capability as something that can be interdicted fairly easily. And I have to tell you, optical communication using lasers cannot be interdicted easily. And, you know, it can be by clouds, but my point here is that there are a lot of ways to get around kind of the traditional thought processes in communication. The next piece is advanced sensors. The only difference between, you know, current radars on board ships today and a radar that can melt UAVs out of the sky is a lot more power going to the radar and better thermal management, right? Then unmanned systems. And you heard me talk about UAVs, but UUVs and USVs, including ships and vehicles on land, can spend days over the horizon at this point. And we can do this and we can get forward in this space, but we need to rethink how we do these things. Isolated forces. So obviously with the Marine Littoral Regiment concept and the organization of forces, they don't have a requirement in the Marine Corps to isolate those forces for 60 days, but in the research and development field, we are asking ourselves, why can't we leave them isolated, at least in the energy space, for 60 days? If I can get away from them having to be extremely tied to the traditional fuel logistics resupply coming every 3 days, then I can allow those forces to remain covered up until they need to shoot and allow them to move around quietly until they need to be able to shoot. Then I hit the reduced signature and then the silent platforms. The other place that frankly energy is helping us is on the profile piece for our forces, because my point here is that one of the ways that you can track forces is the logistics resupply and where that stuff is going. And if I can reduce logistics resupply, I can change the way that the opponents have to look and search for our forces. So my point here is that energy is the basis of the kill chain going forward, whether that's fuel or electricity, whether you want to fly UAVs over the horizon or you want weapons grade lasers, whether you want to generate sorties at advanced rates. This is the basis of a credible force. The MQ-25 that the Navy has been developing increases sortie generation off the carrier significantly. It's a classified number, but it's a significant improvement by simply sticking 5 MQ-25s on board that carrier. You can make huge inroads into the number of sorties and the range of sorties, or the range from which sorties can be executed off of that carrier. So this is my last slide. And I will say that the real question here is, what do we need? We need innovative solutions. We need energy where and when we need it. And we need to use energy only in ways that we actually need it. And so I will tell you that, things that we advocate for in this thing is we look at industry solutions and we look at non-traditional pre-positioning. For example, company-owned, company-operated capabilities, holding assets for us for temporary periods of time and then selling it later and maintaining a store for us in the Pacific is how we do some of our fuel storage in the Pacific. So it doesn't look like, Marine Corps fuel or Navy fuel or Air Force fuel. It just looks like some fuel storage there that is later going to get sold, right? So we can do things non-traditionally in that space. The other place that we're looking at is we're looking at energy assurance in our cooperative security locations. Electrical grids are super vulnerable to attack and elimination as capabilities that can support military operations. And if you want to conduct operations out of some cooperative security location in a place like Thailand, you need to be able to assure that that power is going to be available, or you need to be able to bring your own power. Well, we are coming up with methods or ways to understand whether we're being attacked in this space or not, and developing INW systems that look at power systems, not only from in other countries, but also look at our own power systems to understand when we're being attacked. I will tell you that the Army and the Marine Corps have some weapon systems that the critical point of vulnerability is the generator supporting it, and the ability to attack that generator with cyber capability and take it offline has been demonstrated on multiple occasions. The next place that we should look to industry for is replacement communications. With the way that encryption is going and blockchain encryption and other energy technology that we have going out there, we should be able to do communications across commercial backbones and be able to, at least for short periods of time, have that stuff encrypted. The last piece that we need to look at is non-military infrastructure and getting industry to be able to do things out there where we're supporting industry. Doesn't look like military infrastructure, but it's dual use. Then on the critical technology side of the house, you're going to have heard me talk about this through the entire thing here before, but what we need going into the future is better control. When I say better control, I mean we need energy generated only when we need it generated. So if we use fuel cell technology, for example, fuel cells produce power only on demand. And so that means that I don't have to waste 65% of the power that I plug into an amps generator. I can simply only generate power on demand, and I can make that generator power last a lot longer. The next critical technology is electrification and hybridization. And the example that I will give you is on Navy ships. Right now, the next destroyer that the Navy is putting out there, because of electrification and hybridization, will go at least 25% farther than current destroyers in the fleet. It's amazing what electrification and hybridization do for increase in range and the ability to share power that's traditionally reserved for propulsion and provide it for weapon systems. And so, you know, if you need a really big laser, you can't count on driving around a really big generator to get after it, which means if you electrify your vehicle, you can use the power, you can use a transmission and integrated generator or some other technology that industries come up with to produce more power on that vehicle to give you that. The next critical technology is advanced batteries. I will say this, and for those of you, you know, that read the Wall Street Journal, I was quoted recently as saying advanced batteries are the most critical technology that we have going forward to get any of the things that we want in unmanned systems, whether surface, air, you know, land, doesn't matter. To get anything you want, you need advanced batteries. To get lasers on board ship that don't require a crazy amount of space and a lot more weight, you need advanced batteries. And these advanced batteries come with significant risks. The last thing that we are going after in this space is we're going after hydrogen technologies. Because of the advances that we have seen made in UAVs and in power generation in the R&D community, we think that hydrogen will be a key enabler for the MLR and for expeditionary advanced base operations, and for basically sustaining isolated forces for significantly longer periods of time. With that, that concludes what I have to discuss today. I'll be available for questions at the end of this. I will be followed by Ben Richardson.
Thanks, Jim. That's great. Appreciate the forum, and good afternoon to everybody. This is a great discussion. Similar to Jim, I have a Marine Corps background, but you know, instead of I didn't do the full 20+ years on active duty. I was a reservist, so I went out there into the private sector. So I want to bring a little bit a different angle from the industry side, but good segue there at the end with the critical technologies focus. So, you know, DIU, Defense Innovation Unit, is where I hang my hat these days. It's been around for about 5 years. And we kind of, our tagline at DIU is accelerating DoD's adoption of commercial technologies or dual use technology. So a lot of this critical technology that Jim was just mentioning, we're focused on how do we get those in the hands of the warfighter. We focus around, you know, kind of our accelerate, transform, strengthen kind of mantra, but it really is about bringing new entrants into the DoD ecosystem, players, companies, technologies that would not normally work with DoD. It is a misnomer that Defense Innovation Unit is all about the small players or startups, but half or a little over half of our portfolio companies are startups, but we do also work with likes of Google and other big companies, as long as they have the right solutions. What we're trying to find that. And we're, you know, at its heart, like a rapid contracting, rapid prototyping organization at the joint level. And our real key differentiator, if you boil everything down, is our connection with what's happening in the investment community. So my background's more finance. You'll find a lot of MBAs at DIU, and you'll find a really strong connection with what's happening in the VC world. So who's actually spending money, who's investing, where those dollars are getting doubled down with certain technologies. And lot of insight into some technologies or companies that may not be publicly known yet. One that we worked with for years and years was Joby, which is a kind of a vertical quadcopter type thing for moving about 4-packs. And it was a number of big tech companies were investing in it for years as their kind of future flying car technology. And DIU had been working also with this company kind of in more or less stealth mode for a number of years before they came more public last year. So that's a quick kind of like overview of DIU. If you want to kind of look at the deterrence piece or kind of the why behind DIU's what was placed in existence as part of this kind of play on deterrence and dual use technologies, and kind of quoting the NDS there that kind of looks at this. Technologies are proliferating at a rapid pace. And so it's becoming increasingly important to find ways of getting those technologies to the warfighter in faster and faster ways. So DIU's entire model is focused around prototyping from a new tech that is dual use, that is matured in the private sector, finding the good military use for that, and then within 12 to 24 months, get that out to the warfighter. And so it's finding a way to get at this issue that the NDS kind of highlights and create another level of deterrence as it comes to potential adversaries such as China that also have access to a significant amount of technology in a very globalized environment. So that's the why about DIU and why it exists and what we're trying to accomplish. There's the how we're doing that is we're really leveraging that investment that's taking place in the private sector. This chart kind of identifies that 11x spend. So if you go back 50, 60 years, their DoD government spending was much more similar to what was happening in the private sector. But then you look at that business spend, it just shot up there in that exponential growth, and which will just continue as compared to that federal R&D spend. And so we want to tap into that. And ideally, DIU is targeting those companies that potentially will have in the future 10 or 20% of their business with the federal government or with DoD for dual use technology, and to continue the R&D spend to iterate and improve their technologies and continue to get those best technologies to the warfighter, versus making companies that are solely focused on the DoD marketplace. So that's the why and the how of DIU and what we do. You can see the 6 technology areas that we have here. The 5 there on the right were the original 5 that we've been working mostly for the last 5 years on, and we recently added an advanced energy and materials technology area there on the left. And we call these portfolios at DIU. Each portfolio has a portfolio director. I'm the portfolio director for the advanced energy portfolio. We have project managers that work in collaboration with program offices across DoD and each of these technology areas. And then we have a commercial engagement team with deep expertise from the private sector that it spends a lot of time with the VCs that are investing in these tech areas and making sure that we are constantly aware of what is the next best technologies that are scaling on the commercial side, so we can look for opportunities to make those dual use. And then we have a defense engagement team who's constantly engaging with their DoD partners on what they need and the problems that they're having, curating on those problem statements to make sure that we're matchmaking between the solutions we're seeing in the private sector with the problems that DoD has. Very similar to everything that Jim was just talking about. And that drove kind of where we are now with the creation of our new portfolio in advanced energy and materials. This came both from the demand side, all those issues Jim was just talking about with needing those dual use technologies and needing to accelerate that for DoD, but also what's happening in the private sector side with the investment piece. About 10 years ago, there was also a massive investment in the private sector on energy. It died out for multiple reasons. Most technology wasn't as far along as it needed to be to really scale that on the private side. And they also ran into kind of the financial crisis about a decade plus ago. We're kind of seeing a resurgence of this. And I as much as this, kind of is tied to some politics, it's really not. It's because technology has evolved. It's because of financial mechanisms out here and a tolerance to get more dollars through different financial formats like SPACs and other things into some of these new companies working on some of these problem sets. And those two things converging is perfect for DIU to help the departments address some of those problems that Jim was highlighting. From a DIU perspective, we are not just focused on the operational energy issues, we're also focused on the installation energy issues. But from a deterrence perspective, installations and installations resilience are tied very closely to operations increasingly every day. Installations and their ability to maintain their operations, whether you're talking about bases in the Pacific or bases on CONUS, they are tied to our ability to project power, especially if we start talking about things that can loiter for longer periods of time. So we're focused across those, and I would highlight that they're definitely they're intermingled these days. From a lines of effort perspective, what we're focused and are working on, the storage areas. So this is the advanced batteries that Jim was just talking about. Whether or not you're talking about installations with large batteries for storage or better microgrids on bases to create some independence there, or you're talking about tactical microgrids or energy storage on generators or other issues for the deployed units. Those types of solution sets are growing and abundant on the private sector side, and we want to make sure we exploit those opportunities. And then on the mobility side, we've been working heavily with the tactical vehicle arena on their hybridization efforts. We're moving forward with the Army on this on some of their tactical vehicles. And so this is a great opportunity for us to leverage what has happened in the commercial sector for hybrid vehicles, and everything that Jim was talking about, from longer duration vehicle to everything kind of power output. So you're not draining the battery, you're not draining the vehicle as much, or the anti-idle opportunities here. You can use the vehicles for multiple uses and recharge those batteries on the go, extending the life of the vehicles, extending the range of the vehicles. This is a theme throughout all the platforms, whether or not you're talking about vehicles, ships, or rotary or fixed wing. The need for additional power because the platforms are getting bolted on with directed energy weapons, EW, whatnot, or need to be quieter. These themes keep coming up, and there are great opportunities in the private sector to help solve these at a rapid pace. And then on the materials side, materials kind of gets into a supply chain theme, which kind of cuts across everything. But we're looking heavily at the biomanufacturing world and different ways to produce materials in the private sector that have opportunities to solve some of the supply chain issues or the overuse of certain raw materials. And as that cuts across all three of these lines of effort, we see the movement in the private sector and the kind of the future outlook that certain products and certain capabilities, drivetrains or other things, are going to slowly be coming out of production, and making sure that we're getting on top of these transitions that are happening in the manufacturing arena to make sure that we have platforms and vehicles that are using things that are reasonable in cost, and also just simply available to our future programs as this energy transition happens and some of these vehicles and other platforms change over time. And that all kind of leads to this kind of, I just threw this up there. There's lots of these think pieces out there right now. Bloomberg came up with another really good one this week that kind of focused around batteries. This one's from Shell, which I always find interesting with where the oil companies are highlighting. So, this one, highlights where we're at today with regard to EVs and kind of that shift that's happening and those advanced batteries and those opportunities. But as you start moving further and further to the right, it creates those scenarios that you start, predicting. And again, this is Shell, a big oil company that's looking at where we're going with climate issues and CO2 emissions and just technologies in general, and highlighting where hydrogen kind of comes into play. While there is a lot of commercial dual-use technologies right now on the EV advanced batteries opportunities that DoD should be taking advantage of, hydrogen is still an opportunity later on in 2030 and beyond. and making sure we start shifting into the late 2020s, into 2030 and beyond, if that's going to be how things pan out, and taking advantage of all the capabilities that hydrogen kind of brings into play, which Erik will hit on in more depth here in a minute. So that's my presentation. And just like Jim said, I'll be available for questions later on. Thanks all.
All right, Jim and Ben, thanks for teeing things up for me. My name is Erik Limpaecher. I'll be presenting on our approach to what Jim called changing the rules and our measure of success of trying to eliminate sea lines of communication. This is our work on fuel for contested logistics, what we call the SAFE concept. First of all, I want to thank the Krulak Center and Marine Corps University for engaging with me through the non-resident fellowship. I want to thank the contributors to the concept listed down below. In particular, Art Corbett. He had been contributing to this concept for about 2 years with occasional feedback, and he participated in a peer review about 5 days before his death on the latest version of this, and gave some very encouraging feedback about how this could be the missing link in enabling EABO. So thanks to everybody listed here for their input. So I'm going to present on how hydrogen could enable a viable alternative to bulk petroleum logistics for DoD. And that's based on 3 key developments that have happened over the past 10 years. The first is that commercial industry has made significant strides in developing hydrogen-based platforms that organizations like DIU could act to have the DoD be a fast follower in adopting those commercial capabilities. The second development is there's been a technology breakthrough in the production of hydrogen locally at the tactical edge. And the third breakthrough is that our allies are investing billions of dollars in regional hydrogen production and transport, both in the Pacific and in Europe. And so those 3 breakthroughs, those 3 developments are what enable this concept going forward. So as Jim alluded to, the DoD consumes massive amounts of fuel, has a large number of large fuel supply points, and the transport and logistics of that fuel is significantly costly, both in terms of dollars and personnel. And all of these portions of the supply chain are being held at risk by near-peer adversaries, as opposed to in Iraq and Afghanistan, where only the very last piece, the land-based transport, was held at risk. So any solution needs to address the long-distance transport risks, and ideally eliminate those, address the centralized storage risk, or ideally eliminate those, and address, particularly for expeditionary advanced space operations, the fact that we'll have many, many small, widely distributed units requiring fuel resupply that will strain our distribution resources. So that's the bad news. The good news is that our allies have many resources that we could tap into. In the Pacific, the one resource they don't have is petroleum. Our allies only produce about 1% of world global petroleum production. There are a limited number of JP5 refineries, but there are many resources in the form of natural gas, hydrogen, electric power sources, or other types of resources that could be used as a fuel feedstock. As a point of reference, the United States is the #1 producer of hydrogen in the world. Number 2 and 3 are Japan and South Korea, and that stat is going to be important later on in the briefing. The hydrogen is typically used for industrial and agricultural purposes, and that infrastructure could be used by DoD going forward. But first, let's take a quick look at what some of the fuel options are for DoD and what some of the key characteristics are for DoD. Right now we use petroleum. The risk there is that we require transport over long distances, and as a result, that drives the fully burdened cost of fuel. Even if we're paying $2 per gallon at the pump, the cost of protecting those fuel transport resources in Iraq and Afghanistan added another $40 or so to the cost of the fuel. The reason we're sticking with petroleum is obviously because it's a very mature technology, both in terms of production and in terms of platform performance. So that's for our larger, medium, and large platforms. Smaller platforms require batteries, which suffer from the same issues because they need to be recharged off of generators, the generators that are reliant on petroleum, and because batteries are limited in the amount of energy that they can store, which limits the performance of our small platforms. So if we look at the alternatives, synthetic fuel, which is produced using hydrogen and flue gas, carbon monoxide or carbon dioxide, hydrogen itself, natural gas or ethanol, all of these are available regionally in the primary areas of operation. Hydrogen is unique in that we now have the ability to produce it locally as well. And when you take the fully burdened cost of fuel into account, all of these could be acquired at competitive costs, particularly in a contested environment. We then drill down to some of the other characteristics. Natural gas and ethanol have issues in terms of the maturity of platforms' ability to use those fuels. Hydrogen doesn't have those issues in the sense that there's already large-scale production that exists. It's there are mature commercial products that use hydrogen, and with additional R&D for local production capability specific to DoD needs, it could be made to work for DoD use. So our vision is for a viable future solution for DoD operational energy is based on hydrogen for small platforms, small and medium platforms, and then a synthetic fuel that is produced using hydrogen for larger platforms. And this could address a lot of the challenges in DoD operational energy going forward. So it has three main elements. The first is using cached aluminum to produce hydrogen locally at the tactical edge. In the event that the entirety or majority of your supply chain is out of commission, you can use cached feedstock to produce your hydrogen. Second element is to produce hydrogen locally through a variety of feedstocks, which gives logisticians optionality and potentially also the ability to transport the fuel via other non-traditional means. So instead of relying on the ARGMU and bulk liquid transport, you could use other smaller platforms that can transport solids. And the last piece, which is a bit further out, is the use of synthetic fuel, which takes hydrogen plus flue gas, carbon monoxide or carbon dioxide, to produce Fischer-Tropsch synthetic fuel that can be used to power fighter jets and ships. So I'm gonna focus in on the regional hydrogen production approach and then the local hydrogen production approach today. Hydrogen can be produced through a number of means. The majority of it nowadays is what people call brown hydrogen, produced through natural gas steam reforming or coal gasification. But our allies are investing heavily in electrolysis, which uses any sort of electricity, nuclear or renewables, to produce green hydrogen. So the French, for example, are investing 7 billion euro of their COVID relief money into buying electrolyzers. The Australians want to become a hydrogen production powerhouse by investing in both coal gasification and renewable-based electrolysis. And this has historical precedent. The US Army Air Service used tens of millions of cubic feet of hydrogen during World War II that was produced regionally in factories in France and then transported in these leaky steel cylinders to the front. Don Bishop at Marine Corps University, a military historian, looked through the historical record and could find no combat accidents related to the hydrogen transport, and only one death due to one hydrogen-related death through the flight of these aerostats. These were two-manned aerostats that were used for artillery spotting and surveillance. About 6,000 combat missions that were so hard to shoot down that the Luftwaffe actually granted their pilots 1.5 kills for each balloon that they took down. Hydrogen is already part of the DLA supply system. About 5% of DLA's bulk hazmat shipments are hydrogen. There are 3 national stock numbers for different grades of compressed hydrogen. So commanders could order hydrogen from DLA, and the question is how it would be transported to the units that would make use of it. Technology has improved significantly in terms of safety over the last 100 years. This shows a test by a Toyota of a 50 cal shot into a hydrogen tank. You can see there's no explosion or tank shredding. This test was done after hitting it with a 25 cal, which failed to penetrate the vessel. And you can see that hydrogen, because it is lighter than air, has some safety benefits when properly engineered compared to gasoline, which is heavier than air. So the bottom line is, with proper engineering, hydrogen can be used very safely. As I mentioned before, there are vast quantities of hydrogen being produced, particularly in Japan and South Korea. One calculation showed that if we took all the fuel consumed by Indo-PACOM currently in a year and converted that to the equivalent of hydrogen, that about 19 days of our allies' production would meet Indo-PACOM's annual energy needs. That, of course, is assuming that all the platforms could use it, but just to give you a sense as to how much hydrogen is already produced. And that is before our allies' investments come to fruition. The Australians want to become a hydrogen production powerhouse. Just this one site here in Western Australia, they're investing $36 billion into producing about 2 million tons of hydrogen per year. And there are 13 hydrogen production hubs that they're planning throughout the country. That's in addition to building up the storage and transport infrastructure. The Australians and many of our allies in the Pacific are establishing hydrogen supply chains within the region and outside the region in order to support the growing demand. Hydrogen also provides tactical capabilities or tactical benefits. This is public released info from the Army Ground Vehicle Systems Center, which showed a Humvee, the thermal signature for a Humvee compared to a thermal signature for a General Motors Chevy Colorado that was converted to hydrogen for DoD use. Here, because the diesel engine is running between 5 to 25% efficient, remember that Jim mentioned that much of our fuel running through generators is wasted. That's because if the engine is idle, it's running at this 5% efficiency as opposed to ideally be in the 25% range. And as a result, you see much higher thermal signature and much larger acoustic signature. Fuel cells, they typically run 50% efficient no matter where you are on the power curve, and therefore much lower thermal signature and acoustic signature. And this is on a platform that had zero engineering to reduce signature. So these are COTS breaks, and these numbers could most definitely be reduced further. So that's the story on the regional hydrogen production approach and some, at least one benefit that it has on platforms. Now I'm going to talk about the local production capability. So there's a technology breakthrough which allows us to take aluminum feedstock in the form of, let's say, electrical wire or kitchen foil or BB gun pellets or soda cans, and we take that material and mix it in with a small quantity of activation metals that are available on Amazon.com. They're widely available. And then heat them in just a regular kitchen oven at low temperature for about an hour. It strips away the aluminum oxide that coats the aluminum, almost like aluminum rust, strips that away and turns it into a solid fuel, which when mixed with water, we've tested it with tap water, fresh water, seawater, urine, brackish water. It then produces about half the energy comes off as hydrogen. The other half comes off as heat. And the byproduct is aluminum hydroxide, which is the main ingredient in Maalox antacid. So hydrogen can be used for electricity and propulsion, for aerial lift, for stratolytes. Heat could be used for, we had a MIT master's student demonstrate a water purification system using the heat, or you can use it for field mess or for pressurizing the hydrogen and carbon tanks. So there are a number of applications that you can use both of the outputs of this reaction. This also has historical precedent. The Army used a M1 hydrogen generator using nasty caustic soda to produce hydrogen in the field for barrage balloons that were over the beaches of Normandy and over London during the Blitz to try to prevent against aerial attack. And we have a number of reactors under development with various sponsors to produce compressed hydrogen for use by UAVs, ground vehicles and watercraft, lifting gas, and also an infantry battery charging capability to largely eliminate the need for carried batteries. And down the line, what we're looking to see with this capability is various things like the ability to cache our fuel feedstock at the tactical edge, reusing packaging material or shipping material and turning that into fuel and eliminating retrograde and waste challenges, and then the ability to use merchant logistics to transfer these bulk solids for eventual conversion into a usable fuel. And again, our allies have large quantities of aluminum available. Green shows the primary aluminum smelters in the region, and then orange shows the recycling plants that you can see are widely distributed throughout the region. Japan is one of the leading recyclers of aluminum throughout the world. And you can see through the spread that this gives commanders optionality for sourcing their feedstock if it's not cached ahead of time. And this gets to this last slide gets to DIU's story in the sense that there's been a lot of development in the commercial market in providing hydrogen-based products, particularly in Europe and Japan. So there are a number of companies that provide hydrogen-powered sedans, trains, semi-trucks. There are several companies providing watercraft powered on hydrogen. Airbus has announced they're developing 3 hydrogen-powered aircraft, both turboprop and gas turbine, fueled by hydrogen. There are about a dozen vendors selling commercial hydrogen-powered generators, and a large number of companies working on the storage and transport of hydrogen, throughout the world. The DoD has been experimenting with hydrogen-based prototypes for a while now. None of these have transitioned. I think it's partly because of the single fuel concept and a kind of a chicken and egg problem, where you talk to the logisticians and they say they're not going to, build the capacity to transport this fuel until there's a demand signal from the platform acquisition people. The platform acquisition folks are reluctant to be the first to adopt a platform that operates off of a different type of fuel. So hopefully with some senior leadership, we can get guidance to start transitioning some platforms that run off of hydrogen, and therefore to create the demand signal for the logisticians to be able to supply that fuel. So we have a vision to, as Jim was saying, enable forces to operate unsupplied at the tactical edge for days or weeks by caching fuel, being able to turn it, or caching aluminum, being able to turn it into a usable fuel, and then to power things like field power, water purification, small mobility platforms, ISR, and over the horizon comms and alternate PNT. And then even further down the road, being able to provide mobility through larger platforms, food sustainment for larger echelons, and maybe even the Fischer-Tropsch synthetic fuel for aircraft and large ships. So with that, I think that's the end of our prepared remarks. I'll
Fantastic. Greatly appreciated it, Erik, and all 3 of you. That was just absolutely phenomenal presentation. So I did want to have sort of a brief interlude between the 3 of you. I thought it might be of interest to the audience to sort of have you converse on a few topics that were of interest and relevant to deterrence, and then we'll turn it over to the audience for questions from them. So first of all, are there opportunities in fuel and energy to improve diplomatic relationships with allies and partners adjacent to the South China Sea? And if so, what do these look like? That is the development of infrastructure that provides energy needs for partner nations, but also a ready means of providing fuel for US DoD if needed. One of the specific thoughts that I was having, particularly listening to Erik's talk, was the potential crisis, impending crisis in the Philippines with respect to natural gas, and how are the things that we can do for diplomatic relations that potentially can affect that.
I guess I'll start. I think there definitely is an opportunity or an imperative to engage with our allies, given that there are billions of dollars being invested in hydrogen production and transport infrastructure. And if located in a way that DoD could access that as a fuel, I think it's a great way to re-engage with our allies and build up their alternate fuel capabilities and transport capabilities in a way that could support DoD.
So from my perspective, like, we don't advocate for biofuels, but we work with the Australians quite closely on the potential to produce Jet A1 compatible biofuel in Eastern Australia, because that literally takes the significant number of days out of the supply chain for moving fuel into the South China Sea region for an exercise or for an operation. And we already do that already with the Australians. And we also cooperate with them in the advanced battery space very closely. As a matter of fact, it's almost every other week we are trying to bring them on board to U.S. naval standards in advanced batteries so that we make sure our forces are interoperable going to the future. And this also then ties to our ability to use their batteries produced locally in Australia in the event of, critical operations. And so with the Australians, we're very close in that particular space. With some of the other countries, we're a little bit leery. For example, the only other biofuel produced in the region is in Singapore, and we're not assured of access in all particular tactical scenarios. And so sometimes we don't know whether to trust or not. Over.
Yeah, and I go ahead, Eric.
I guess I have two other comments. One is that the synthetic fuel that I mentioned. Some people might think, oh, that's advanced tech, but that's actually a commercially available fuel. So there's about 10 million gallons per day that's produced, and one of the main plants in the world is in Malaysia, already producing that Fischer-Tropsch synthetic fuel. So that's the one thing. The other thing is that our European allies are really keen on purging Russian natural gas from their pipelines. And so there's you'll see it in all of the national hydrogen strategies in our allies in Europe. And there was recently an announcement that they're planning on basically building up a hydrogen supply pipelines that will allow them to replace much of that natural gas in the pipelines with hydrogen. Some of it will be using existing pipeline infrastructure. Other parts of it will be using new pipeline infrastructure. So as those capabilities get built out, that could be a ready source of fuel for DoD operations. Ben.
Yeah, I just add to Eric's comments in this presentation. If you overlay some of the quad kind of concepts that are coming out of the administration for the new national security policies, I mean, it overlays nicely with what Eric's showing in his map of different fuel options, whether or not you're talking about hydrogen or some of these other synthetic fuels he was just mentioning. So there's definitely opportunities to partner there and work across all those areas. From a DIU perspective, we have our biggest ties are with Australia in the area. We do projects with them now. We work with their government on different things on the innovation front and have lots of tie-ins there. As a new portfolio focused on energy, there's building a relationship, and we'll see where that goes. We have a little, I think, more leeway from some of the commercial tech and dual use stuff, and we are working with partners like Japan and Korea on different technology exchanges with them. So there's other opportunities there.
Great, appreciate it. Thank you, gentlemen. Second, if we in the U.S., in conjunction with these allies and partners, are able to manage the fuel and energy liabilities with the difficulties of distance and in inhospitable environments such as the South China Sea, are there additionally opportunities to take advantage of adversary fuel and energy needs and liabilities, and how might some of these look?
So there's a really fascinating book by Peter Zehan. He's a geopolitician, called Disunited Nations, and in it he has a map. I'll dig it up and I'll put in the link here. That talks about China's petroleum challenge. I think about 85% of China's petroleum comes in via shipping, primarily through the Malacca Straits. Maybe about 15% comes in through a pipeline through Russia. So, if those sea lines of communication are shut down, then China also has some fuel vulnerabilities. And as Jim mentioned, they've built up their national petroleum reserve during the glut, recently. So I think that just like we have challenges getting fuel into the Western Pacific, others do as well.
So from my perspective, from what I read of what the Chinese are trying to do in expanding, their, belt, one road and things like that, they're trying to be able to assure their fuel supply lines. And that includes extending pipelines through Central Asia and Pakistan, potentially bypassing the Straits of Hormuz, for example. And so that's a potential option. The other issue here is that I don't know what the current number is, but I'm sure they're on par to own about 50% of global fuel transport going forward. And so they're going to be a transport capable nation. And the last time I read an article on this, they were capable of storing about 96 days of strategic reserve. And that is a really big number because I didn't say military reserve, I said national strategic reserve. And so in that space, it complicates issues. And they're becoming more complicated with the advanced technologies because the supply chain required for advanced batteries and for solar technologies and things like that comes from other places in the world, just like oil and everything like that. So predominantly a lot of these critical minerals come out of South America and Africa, and there's a book on China and Africa if you want to look at it. They have good influence in this space, but they are going to absolutely have to be able to transport things like cobalt, nickel. I mean, the same challenges we have with those materials going forward. And so I would tell you that this problem's only going to get worse. It's just moving from oil to something else. The last thing that I would say on this is please remember that the Chinese looked at US capability to resupply at sea, and they're one of the few other naval forces that also practice this. And so they have that capability as well. And that vulnerability associated with that capability, though not quite to the extent of the US, because we do everything on NIPRNet in this case. Over.
Yeah, I guess the only thing, I mean, worked with a brand study like 20 years ago when I was doing my undergraduate work, and kind of the point of that was different scenarios laid out, and it talked about how we all know about the choke points, the challenges China would have with energy. The kind of the comment behind that entire work 20 plus years ago was on the U.S. Ability to influence China will greatly be affected by our relationship with Russia. Because that's where they're going to be looking for energy sources, more traditional energy sources if we're able to actually control some of those choke points. But I mean, obviously, this is why China is so interested in South China Sea and others. But I guess I'd also highlight from a technology perspective here. This is interesting as this plays out from a goals that the Chinese Communist Party are putting for renewable energy and other things inside the country, advanced batteries that they're focused on, other things, because it does decrease the reliance. A lot of this is being spoken with regard to climate change and other initiatives there, applying with the Paris Accords. But I look at these very similar technologies that also provide some independence from these choke points that will be problematic if we get into some kind of more intense situations with China.
Excellent. Greatly appreciate the insights from all of you. So I will go ahead and open it up to the audience to ask questions of our incredibly knowledgeable panel.
All right, thanks, Dr. Wilhelm. And I put in the chat, and I'll reiterate here for anyone. I'm looking at the time, I realize we're past an hour, but if you do have a question, go ahead and throw it in the chat and give you a chance to ask it before we reach the end here. I did have something I wanted to actually throw out, and it kind of jumps off of what Erik was mentioning there. He mentioned Russia as one of the considerations, and we started this series looking at regaining the strategic initiative in the South China Sea, right? And then Russia starts moving its troops up to the border of Ukraine. So the world doesn't always want to cooperate. So looking at that, though, in an Eastern European or even an Arctic theater, are there any other unique considerations in terms of operational energy and how it affects our deterrence in that environment? Different from South China Sea, are there any, whether it's geography, method of delivery, environmental factors, looking at, if there's going to be less ice up there, even, does that make it an easier problem set rather than a harder one? Just in general, what are some of the similarities and some of the differences in that environment?
So I'll tell you, key similarities is that we're dealing with is you got to go through restricted lines of communications to get through that, whether you're going to run through the Bering Sea or whether you're going to run up beside Norway on this particular space. And some of those places can get much more extreme weather. So when we talk about South China Sea conflict, for, the Marines and former Navy in the room that have transited the South China Sea area and the Celebes Sea and the Sulu Sea, sea states are generally pretty low. North Sea, 50 feet is something you have to deal with in the winter. So completely different things that constrain operations in the 6th Fleet AOR, which is, the European theater and north up there. The other challenge that we, will get into is that given our current platforms, if we start operating the fleet, in those environments, we're going to be consuming more fuel, regardless of the fact that ice is going away. It's still going to be seasonable. It's still going to be cold in the winter up there. And, the requirements to support Arctic operations for things like that are not insignificant, and they present challenges to advanced batteries. So, this from your cell phone. If you put your cell phone on the seat of your car and it's 120 outside, then you can't use your cell phone until it cools down. Or if you go outside in the morning in the middle of winter and it's 15F outside, then your cell phone drains inside of 2 minutes when you try to talk to somebody on it. And so advanced batteries will be challenged in this space, and fuel logistics will definitely be challenged in this space. And that is, I think, further challenged by another near peer competitor's ability to target broadly across that zone. So unique challenges, but at the same time similar. Over.
Yeah, I mean, I would agree with everything Jim said, and some of the reasons DIU has looked heavily at hydrogen, which Erik can speak more about, is like some of these issues you will have with batteries, advanced batteries in the Arctic and in extreme conditions. So hydrogen gives us more options there.
Erik, did you have anything to add on top of that?
No, I think they covered everything. I guess I would just echo the challenges with batteries operating in a cold environment, and that's there's some approaches to incorporate heaters into batteries in order to allow them to operate a little bit more in their sweet spot. But there again, it drains them. So either if it's heating internally or heating externally, there's an additional energy draw. Not to mention the challenges with running combustion engines in a cold environment. As anybody in Alaska will tell you, they need to, in many cases, preheat their engines in order to get them to start. So, there are some unique challenges, and I think in many cases, requires some special engineering considerations in order to be able to make those systems operate.
All right, thank you very much, gentlemen. And I don't have anything else in the chat, so barring any last-minute pop-ups, Dr. Wilhelm, I'll let you have any final comments or thoughts before we say farewell.
Greatly appreciated, Ian. Phenomenal discussion. Greatly appreciated. I really enjoyed hearing from all of you. It lays the foundations, I think, for a lot of the thoughts that I'm having about sort of future events. So I think I really, again, greatly appreciate your time, and particularly all three of you being available on one day to have the interplay between the three of you, which I think was incredibly educational. So thank you all, and thank you to Ian for this platform, because I think it's been a great opportunity.
Yeah, thanks for having us, and thanks to the Krulak Center.
Thanks, folks. Have a great night.
Thank you.
Great.
Thanks, Ian.
Thank you all. To everyone left in the audience, thanks for joining us this week's Brewcast. We got a number of episodes in motion as we approach the end of Marine Corps University's academic year. So make sure you're following us on social media or our email distribution list for announcements on the dates and times for the next Brewcast. And we hope you all join us then. Thank you.
Education is what's important. Training, preparation for the expected. Education, preparation for the unexpected.